In this lesson, we're going to look at what we call simple equations. These are the equations that you learned in probably like 6th grade or 7th grade, and we're going to go through a process of writing our steps down because the equations that we look at in chapter 1 get significantly harder, right? This is only lesson 1.1. There's more lessons to our equations unit. So while you might say to yourself, oh, come on, Miss Lean, I can just punch this in my calculator or I can do it in my head. If you haven't set up the process of how to solve an equation, you're going to just be really stumped when it gets to the harder ones. So while it might seem like overkill, what I'm asking you to do for these examples, it's really going to set you up for success in the future equations. Now, in order to solve equations, you have to know what inverse operations are. So, do you know what inverse operations are? Inverse operations are operations that undo each other. You probably already know some inverse operations. Addition is the inverse of subtraction, and then subtraction would be the inverse of addition, and then multiplication is the inverse of division. You probably already know those. So we're going to use those inverses, and we're going to learn more inverses as we go through this chapter and also throughout this year. So when you're solving an equation, the first question you want to ask yourself is, what operation do I have? And then you ask yourself, what is the inverse of that operation? So in example 1, or letter A, right, example 1A, I say to myself, I have subtraction right here, because you look at the goal is to get the variable alone, so we have subtraction. So then you say to yourself, what is the inverse of subtraction? And we already went over that the inverse would be addition. So I'm going to add 7 to both sides. A lot of teachers like to put a line down the equal sign just to kind of separate the two parts. It's really up to you whether you want to put the line down the equal sign, but you want to do it once to the left side of the equation and then again to the right. Now, positive 7 and negative 7 cancel each other out, so I'm left with just x. That was the point of adding 7, to get the variable alone. And negative 6 plus 7 is positive 1. So my answer would be x equals 1. Now the directions say to check the equation. So the way that you check it is you take your value and you plug it back into the original equation. So in the original equation, instead of x, I'm going to put 1. So it's 1 minus 7 equals negative 6. And you do your calculation, right? Punch it in your calculator, do it in your head, however you want to do it. 1 minus 7 is negative 6. And so since you get negative 6 on both sides, then it checks. You can put a check mark, you can put a smiley face, whatever you want to do. Okay, now let's look at example B. So you say to yourself, what operation do I have? And you look at the variable, you have addition, so the opposite would be subtraction, or the inverse. So I'm going to subtract 3.4 from both sides. And I'm probably going to get out my calculator because I don't know 0.5 minus 3.4 on the top of my head. So I'm going to punch it in. 0.5 minus 3.4. And that's negative 2.9. Now, I'm definitely going to check. So in the original equation, instead of y, I'm putting negative 2.9. So I have negative 2.9 plus 3.4. And I'm trying to see if that gives me 0.5, so I'll go to my calculator, do negative 2.9 plus 3.4, and I get 0.5. So I got 0.5 on both sides. I like to just do a check mark, so we'll do that. Now, in letter C, you've got this fraction, and everyone freaks out with fractions. There's 2 ways to do it. So the quickest way is to do what we call multiply by the reciprocal. That would be the inverse of multiplying by a fraction. We're going to multiply by the reciprocal. The reciprocal is when you flip the fraction. So the number that I'm going to multiply on both sides is the reciprocal of negative 3/4. So I'm going to multiply by negative 4/3 on the left and multiply by negative 4/3 on the right. So these cancel out, and I just have n. I didn't do the line down the equal sign, but no big deal. And now I have negative 2. I'll put it over 1, because when you're multiplying fractions, you want to have that. And now I'm going to multiply the numerators, and I'm going to multiply the denominators. So negative 2 times negative 4 is positive 8, because a negative times a negative is a positive. And then I have 1 times 3, which is 3. And 8/3 doesn't reduce. It doesn't go divide evenly. If you want to write 2, let's see, what would it be? 2 and 2/3, I guess, as a mixed number, you can. But I would definitely suggest that you just leave it as 8/3. So you get a fraction, and everyone freaks out, like I said, when you have fractions. So let's check it in our calculator to make sure that it is correct. So we have negative 3/4 times, I'll use the dot, 8/3. I'm not going to use the x because then it looks like a variable. So negative 3 times 8 is negative 24, and 4 times 3 is 12. And when you do that division, negative 24 divided by 12, you actually do get negative 2. So I got negative 2 on both sides. In class, I'll show you another way that you can solve it without having to multiply by the reciprocal. All right, so last one-step equation would be letter D. And we have a number right next to a variable. And anytime you have anything next to a variable, no matter what it really is, it represents multiplication. So this is multiplication. So I'm going to do the inverse, which would be dividing. So I'm going to divide by 0.09 on both sides. And again, I have absolutely no idea what that is. So I get my calculator out, and I'm going to do 1.8 divided by 0.09, and I get 20. So let's check it. So I'm going to rewrite the original equation, but now instead of W, I'm going to put 20. And 0.09 times 20, type it in my calculator, I get 1.8, and that's what I wanted, so I know that it was the correct answer. Now we're going to look at what we call two-step equations, and two-step equations differ from one-step equations by their name. One-step equations only have one step, one inverse. Two-step equations have two steps, so they're a little more complicated. You have to pay attention to what operation to get rid of first, and we're going to kind of progress through these as we go through Chapter 1. Now, when you're trying to decide which operation you want to get rid of first, you have to remember PEMDAS or GEMDAS. I'll call it GEMDAS because G stands for grouping symbols, but they're both the same. You could say P is parentheses, but G is more general. It says all the grouping symbols, not just parentheses. So we know GEMDAS, that's our order of operations. What we're going to do is we're going to use our inverses, and we're going to go in the backwards order of GEMDAS. So if I had, for example, in letter E, I have multiplication and addition. If I'm going backwards in GEMDAS, I'm going to get rid of the addition before the multiplication because I'm going backwards. So the way that you get rid of the addition is by subtracting. So I'm going to subtract 2 from both sides, and I bring down what's left. 3x equals 12. Now this is different than the last one because now we have a second step to do, right? So now I have multiplication, and I'm going to undo that with division. And so the answer would be x equals 4. If you wanted to check that, you would do 3 times 4 plus 2 equals 14. We're going to plug in 4 where the x is. And now, since we're not solving, we're just, well, we are solving, but since we're not doing inverses, we're just going to go in regular order of operations forwards. So 3 times 4 is 12, and 12 plus 2 is 14. So that was correct. It gave me 14 on both sides. All right, the last two-step equation that we're going to look at is letter F. And if I go backwards in GEMDAS, first I have to decide what operations I have. So I have division here, and I have subtraction. So now if I'm going backwards in GEMDAS, I would hit that subtraction before I hit the division. So let's get rid of that subtraction first, and I get rid of subtraction by using addition. So I'm going to add 6, and I'll get a over 3 equals 14. And now I get rid of division by doing multiplication. So I'm going to multiply both sides by 3. I don't know what that is off the top of my head. Let's see. 14 times 3 is 42. So now I'm going to check it by plugging it back in. So I have 42 over 3 minus 6 equals 8. So let me get my calculator out to do 42 divided by 3. And I get 14. 14 minus 6 gives me 8, so I get 8 on both sides. Alright, I'm going to ask you to pause the video. I'll give you a little tip. I want you to try example 2 on your own. So here's what it says. What value of k makes the equation k plus 4 divided by 0.2 equals 5 true? So what you're going to do, since this is a multiple choice, you're going to take these choices one at a time. You're going to plug them in for k. You have to follow the order of operations. Division comes before addition. And see which one gives you 5. So pause video, circle your choice, and I'll tell you what it is in just a moment. Alright, I got negative 15. Choice A is the correct choice. You had to remember to do that division before you do the addition. And now let's wrap it up. Let's look at example 3. The temperature in a crater on Mars is 0 degrees Celsius at 1 p.m. The temperature decreases 8 degrees Celsius every hour. When will the temperature be negative 50? So here's a word problem, and they've given us a little verbal model, so they told us how to set up the equation. The change in temperature is equal to the hourly change in temperature times the time. So let's look in the store to see what they gave us. They told us that the hourly change in temperature is 8 degrees Celsius, is decreasing. The change in temperature goes from 0 degrees Celsius to negative 50. So I have to use those two pieces of information to realize that it went down 50 degrees Celsius. And it says when, so that gives me an indication that I'm looking for the time. So here's how I would set up this equation. I would say the change in temperature is negative 50, and that's equal to negative 8, because it's decreasing 8 degrees every hour, times the time in hours, so I'll just use H for hours. And this is a one-step equation. It's not subtraction because there's a number right next to a variable, so that stands for division. So I'm going to divide both sides by negative 8, so 50 divided by 8. I know a negative divided by a negative is a positive, so that would be 6.25. But that's not the answer because it says when. 6.25 is not a time. It's 6.25 hours after 1 p.m. because they tell us that it's at 1 p.m. So 6.25 hours after 1 p.m. would be, I guess if you say like 7.25, but that's not how you say time. 0.25 is 1/4 of an hour, which represents 15 minutes. So it would be 7:15 p.m. So it would be 6.25 hours from 1 o'clock, which would be 7:15 p.m. All right, if you have any questions, write them down and ask me when you come to class.